So in this video, I'm going to replace the solid state relay that I put into this with one of these little tiny mechanical relays. And the reason why I'm having to do this is it turns out the thing that this is going to be powering, one of these air pumps that a buddy of mine wanted to be able to turn on and off with this kind of device. It still kind of is on when the solid state relay is turned off. It kind of buzzes. I don't know if you'll be able to hear that or not, but it's still kind of buzzing. It's not blowing any air or anything, but it's kind of vibrating. The motor inside is still kind of vibrating a little bit, even with the solid state relay off. If I go and I turn this on, you'll be able to hear, it's full normal thing, and you can feel it vibrating really strongly. But if I go and turn this thing off, it still kind of runs. It's still got a pretty decent noise that it's making. Vibrates a little bit too. So yeah, I bought a couple of these things, really tiny, really cool how small these things are. And I got a little circuit set up with it. Here's the updated schematic for the project. Rather than having the solid state relay connecting over to pin or D3, I'm going to be having that connect to a transistor, and I'm just going to be using a transistor that can handle the current that this thing needs. I got it measured here. It's about 60 milliamps to engage the mechanical relay, and just going through a 1K resistor seems to work okay. And here is the mechanical relay and 5 volts in the ground. So the little mechanical relay that I got here, it's got several connections on it. There's a common, a normally open, and then a normally closed. Then these two pins here are where you apply the voltage to connect the common to the normally open pin. If you don't apply a voltage between these two pins, then the common and the normally closed pin are the two that are connected. So you want to use the normally open and the common pin to have your AC switching on and off when you apply the 5 volts across it. This one is a 5 volt relay. You can get them with different voltages, but you can see this one's set up to be a DC 5 volt ones. So yeah, that's the relay's connections. And because when you do apply the voltage across these pins, it does need a little bit of current. It takes about 60 milliamps, as you can see I'm measuring here. And that's more than one of the pins on the AT-Tiny85 can source. I think these can do up to 40 milliamps. So because of the 60 requirement, that's why a transistor is involved. I'm using an NPN transistor, which you want to put on the low side of the circuit rather than switching the high side. And the other little part is this diode that's in here. And it's backwards right here, so when the conventional current flow it comes from the positive voltage, and it can't go this way because there's the diode it's reversed biased. So it has to go through the electromagnetic coil that's in here, and then it comes through here. But when you turn off the power, this coil here has got a magnetic field, and the magnetic field collapses, and supposedly that can create a very high voltage spike. And the voltage spike is so great that the rating on the transistor that I'm using here, which is this one, I think it's about 40 volts. This voltage could be way above that and blow out the transistor. So to give the high voltage a path back up to your source, you can put this diode in backwards and protect your transistor from that voltage spike. I'm not sure what happens when the voltage goes back up here, the really high voltage. I guess the source can take it, which in this case is just a battery, but in the case of this thing, it's going to be this 5 volt power supply. Here's what I'm thinking about for the perf board layout. So I bought, when I ordered the solid state relay, I also ordered some of these terminal connectors, so that rather than having just a solder joint on the hot line that gets switched, have a mechanical joint as well, and then just the other little parts. I'm going to put a little 3-pin connector on here because I need to have 5 volts ground and then the switch to turn the transistor on and off. Here's the finished relay module all put into place, and I did plug this in already and it is working just fine. Now when the lights go out on the front, the relay disengages the power line, the hot line here, and it totally turns off just like I was hoping it would do, and it's working out pretty well. So the header on the side here is where I'm getting the 5 volts in the ground, and then the switch. So the blue wire is the switch that's going over to the ATtiny little circuit board. So yeah, it worked out pretty well. The solid state relay is a lot easier to work with because you don't have to deal with all those extra parts, but this one didn't turn off all the way for this particular application. This little guy, and this is little, if you can see, it is very small. This worked out really well. It just turns all the way off, and you just have to deal with a little extra circuitry to use these things. Another thing that was kind of a pain in the butt was the pins aren't 0.1 inch spaced, so to get them into the circuit board, the prototyping board here, was a real pain. Even getting into the breadboard, this is the one that I had on the breadboard, you've got to bend all of them just a certain way, and then it will kind of go in. The common line, it really had to be bent a lot to get it to work right. But besides that, definitely some pros and cons to each one of these. So it really depends upon your application, what you want to use. But definitely I need to do more research on these relays next time. I actually bought 3 total. I bought one of these that was a DC one, then I bought this AC one, and finally went with just a mechanical one. So a little bit of learning on the relays on my part. But it's all working well. I'll get this buttoned up and off to my buddy. Hopefully it'll work out well for him.